If sine 2a equals 5/13, express in surd form the two possible values of sine of a, where a lies between 0 and pi over 2 radians. This is 90 degrees. So, we could look at double angle identities for sine 2a. Here's one of them. Sine 2a equals 2 sine a cos a. So if sine 2a is 5/13, we can try and solve this equation to find sine a. So we'd have to find sine a here. The only thing is, what about cos a? Well, we can actually get cos a in terms of sine of a using the following identity. Sine squared a plus cos squared a equals 1. So I'm using this identity in conjunction with this identity here. If we make cos a the subject, you see we've cos squared a equals 1 minus sine squared a. And if we just want to get the cos of a, then we get the square root of both sides. Square root of cos squared a is cos a. And then we get the square root of 1 minus sine squared a. So we could write 5/13 as 2 times sine a times the square root of 1 minus sine squared a. Now, what do we do with this? Well, we could square both sides, because everything is multiplied together here on the left hand side, so squaring this won't be too much of a mess. These are multiplied together, so we just square each of them. 2 squared is 4. Square this to get sine squared a. If we square this here, we get rid of the square root sign. And square the right hand side to get 25 over 169. Now this might look like a mess, but in order to simplify this, I will let sine squared a be x. I just call it x, so it's easier to see what's going on. Ultimately, we have to solve for sine of a. We want to get sine of a in surd form. So let's just make this easier to read by putting x in for sine squared a. So now you see we have a quadratic equation in x, so we can solve this for x, and once we found x, well, if it's a quadratic equation there's probably two values of x, we can then equate x to sine squared a to find the two corresponding values of a, or sorry, sine of a. We just take the square roots. So let's get this quadratic into standard form. We don't have 0 on the right hand side, so we can't just equate each factor to 0. So we 4x minus 4x squared equals 25 over 169. I'll just change all the signs to make the x squared term positive for convenience. Plus 4x squared minus 4x. I have to bring this over, change the sign, and then it becomes positive. And standard form means 0 on one side. Next we can multiply all of this by 169. Now I'm not going to bother even trying to factorize this thing. So using this formula, we've minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So I'll just take the bit under the square root sign, plug that in. We get this, and I want to get the square root of this number, so I'll put it to the power of a half. That's very convenient. It turned out to be a square. 624, so we have 676 plus or minus 624, all divided by 2 times 676. So now that's two values of x, and since x is equal to sine squared a, we know that sine squared a equals each of these, so we just have to take the square roots. Now I've divided above and below by 2 here. Well, the fraction button on your calculator will simplify this fraction down to its simplest form. Anyway, if I break it down here, 650 is 25 times 26. So one of the factors of 650 is a square, 25. Obviously if it ends at 0, well, if it ends in a 50, 25 is a factor. So that's how I know from looking at the last two digits. So try to factor out a square if you want to simplify this surd. 676 is actually 26 times 26, but your calculator will give you the simplest form anyway, so we end up with the square root of 25 over the square root of 26. So in simplest surd form we get 5 over the square root of 26. So this is one of the values for sine A, and of course to get the other one we just go to this here. So breaking this one down, we get the square root of 1 over 26, which is 1 over the square root of 26. Now I could have done this question another way by considering the other double angle identity for sine 2a. This way is actually easier. Sine 2a is 2 tan a over 1 plus tan squared a. You can just look this up, set it equal to 5/13 and solve for tan a. And once you know what tan a is, you can find sine of a. Now to make this easier to read, I'll just call tan a x. So we have 2x over 1 plus x squared equals 5/13. X equals tan of a. So we have to solve this equation for x, and it's obviously a quadratic, so 26x equals 5 plus 5x squared. So we 5x squared minus 26x plus 5 equals 0. This can actually be factorized, so we get two solutions, x equals 1/5 or x equals 5. So x is tan a. If tan a equals 1/5, we can find sine a by just constructing a right angle triangle. Here's angle A. Tan of A is opposite over adjacent in this right angle triangle. Side opposite A is 1. We just make the side opposite A 1, make the side adjacent to A 5. Now we want the sine of A, so that involves the hypotenuse. That's where Pythagoras comes in, so we have root 5 squared plus 1 squared, or root 26. And we can see from this that sine A is opposite over hypotenuse, 1 over root 26. Over here then, we have tan A equals 5. So if I make the side opposite A 5, make the side adjacent to A 1, so tan of A equals 5 over 1, which is 5. Now the hypotenuse here is also root 26, root 5 squared plus 1 squared. So you can see here that sine of A is opposite over hypotenuse, 5 over root 26. Actually, the second way of doing it is a lot easier. Next example. If t equals tan a over 2, prove that sec a plus tan a equals 1 plus t all squared all over 1 minus t squared. So here we have a half angle, a over 2, but we can use one of the double angle formulas proved in previous videos to write tan a in terms of tan a over 2 and also sec a in terms of tan a over 2. So I'll write down the double angle identity that we will use. I'll write it over here. Tan 2a is 2 tan a divided by 1 minus tan squared a. Now, how do we use it here? We have tan a over 2. What we do is we get this identity from the tables, of course, but we replace a here with a over 2. Okay, so you'll see this in tables, and if a is a over 2, then this angle here is 2 times a over 2, which is a. So that's how we get tan a, and that's what we need here. We need tan a. So let's get tan a first of all. So let's make that substitution. We see that tan a is 2 tan a over 2 divided by 1 minus tan squared of a over 2. Okay, you could call this a half angle formula, but I prefer to call it a double angle formula. So you normally won't see this in tables, but you'll definitely see this. Well, usually you'll see this. So make that change, and now we're letting t equal tan a over 2. So we have 2 times t on top, and here we have t times t squared. So there's tan a in terms of t. Now what about sec a? Well, sec a is actually 1 over cos a. You'll see this in tables. And we can use another double angle identity for cos a. Well, actually you won't see it as cos a, you'll see it as cos 2a. So I'll make a note of that. Cos 2a. This is 1 minus tan squared a over 1 plus tan squared a. So you look this up, and like before, we replace a here on the right hand side with a over 2. And this angle out here must be twice this angle. But 2 times a over 2 is a. So this angle will become, so 2a will become a, and then we'll have cos a. And that's exactly what we want here. So we want 1 over cos a. So 1 over this thing here, where a has been replaced with a over 2. So we've 1 divided by this. Well, that's the same as 1 multiplied by this thing inverted. Or you can multiply above and below by 1 plus tan squared a over 2. But anyway, you'll get 1 plus tan squared a over 2 divided by 1 minus tan squared a over 2. So remember, t is tan a over 2, so we need to plug in t for tan a over 2 here. So we're going to get 1 plus t squared over 1 minus t squared. Now we have to prove that sec a plus tan a is 1 plus t squared over 1 minus t squared. So we have to add these two fractions together, and hopefully we'll get this fraction here. So we have to add these two together. This is going to be sec a plus tan a. Well, both of these fractions have the same denominator, so the common denominator is 1 minus t squared, and we just add the numerators. So we have 1 plus t squared plus 2t. Now 1 plus t squared plus 2t is the same as 1 plus t all squared.